One thing that can make us appreciate U substitution a little bit better is to try this on our own. Can we think of it a function whose derivative would be square root of 1 minus x? And I certainly would have a hard time. I know it's got to be to 3/2 power. That way the 3/2 comes down and multiplies. Then it gets reduced by 1. Oh, but there's a chain rule happening. I need to multiply that by the derivative of the innermost function. It's hard to sort through all those facts without making a substitution. Okay, so we can simplify this. Let's let u be the entire inside of that square root. Let u be 1 minus x. Du, which needs to be there if we're going to make the substitution, would be negative 1. Right? The derivative with respect to x would give us negative 1. So I can get that by just multiplying the outside and the inside by negative 1. That would balance out because you could multiply them together and make positive. Right? So we've got our substitution. Now this is different from some of the other problems you might have done because we have the limits of integration in this. Those are with respect to x. So we've got to drop those temporarily and we'll add them in. Maybe we can put placeholders a and b because now we're in u land, right? That's a different place than x land, so we can't have the same limits of integration. This is our u, this is our du, so we've got our full substitution. Now we can just focus on finding that antiderivative. This is a 1/2 power, so I know the power needs to go up by 1. But then when I take a derivative, I'm going to be stuck with an extra 3/2 coefficient, so I need to balance that out with the 2/3 down here. There's that a and b. Well, now that we know the antiderivative, we can put things back in terms of x, including those limits of integration. This is 1 minus x to the 3/2. I just realized, am I doing the same problem? No, I'm doing something similar. We do that from 0 to 3. Okay. And I just realized the original, I made this one up on the fly. 3 is not part of the domain, so you can't evaluate this any further from my problem. I shouldn't have even begun. But whatever your problem is, if it's from the textbook, you can keep evaluating it. This is the part where you plug in 3, then subtract what happens when you plug in 0.